Hi, this is the beginning of Unit 1 Physics. We are into the actual physics and we are out of the pre-physics unit. Unit 1, the language of motion. It's been said that to be ignorant of motion is to be ignorant of nature. In Unit 1, we will begin a study of motion, starting with some relatively simple examples. We will progress from simple motion to more complex motion in later units. These are the various ways to describe motion using words. It could be fast, slow, could be jerky, could be stop and go. The list could go on. But in physics, we also wish to use numbers to describe what we see. The two main quantities that we are able to measure in this class, things that we can measure, are distance and time. Distance, we have meter sticks, we have tape measures. Distance is relatively easy. Time, we have stopwatches, but everybody has a cell phone with a stopwatch now, so everybody has access to a time mechanism. We also want to describe motion with the concept of speed. Speed. Can we use distance and time to describe how fast an object is moving? Talk about distance, that's how far it's moving. Time, how long did it take to move? Is there a way that we can figure out how fast an object moves? There are two possibilities. We could use distance over time. Or, second possibility, time over distance. So which one is better? We have two possibilities and they are both describing the relative nature between distance and time of an object as it moves. So which one's better? Well, let's take a look at each one. Let's take a look at time over distance first. It is useful in some cases. It's useful in some cases. Some places where you might see this: track, swimming, cross country, etc. This is where you're talking about things like, I run a 7-minute mile. That's time per distance. Which one is better? Let's look at distance over time. When you do distance over time, we find that a bigger value means faster. So distance over time, I went 2 miles in 1 hour. Not very fast. If I went 4 miles in an hour, the number is twice as large. A bigger number means I was moving faster. If you look back at your time over distance, smaller number is faster. If you run an 8-minute mile, the person who runs a 6-minute mile will beat you. And this one, a smaller time, smaller number is faster. This brings us to our first formula. Average speed. Speed in physics is really not as common as velocity. There is a difference, and we will address it soon. But average velocity equals distance over time. In symbols, average velocity equals delta D over delta T. Why the deltas? A triangle. Why the delta? Delta means change in. So we are looking at the change in distance divided by the change in time. Can we get rid of the deltas? Here's what we're looking at. Looking at delta D. What we have is D2 minus D1. Or you could say D final minus D initial. Another possibility. In simpler symbols, average velocity equals distance over time. Where have we seen this before? Your math class. Distance equals rate times time. These are more of your math formula symbols, and over here you have your physics formula symbols. In this unit, we use them somewhat interchangeably, but remember that this is your physics formula. V average equals distance over time. How has it changed from math class to physics class? We had distance equals rate times time. Here's our new symbols. Lowercase d for distance equals average velocity times t for time. Something useful that the previous physics teacher, Mr. Duff, showed the class, a very helpful tool, is that when you're looking at a formula like distance equals rate times time, you can draw this circle that looks like this. And what you're going to do, and I'll write it off to the side, cover the one you are looking for. It's a helpful trick to make sure that you're on the right track. So let's say that we are wanting to know distance. Well, how do we know distance? I'm going to test something here. Oops. Okay. Cover up distance, and what you have is rate times time. We are looking for distance, and so the formula is rate times time. If, for example, I want to know the speed or the rate, the velocity, that's r, I'm going to cover it up, and what I have is distance divided by time. Same thing if I would like to know the time. Cover up time, and what we have is distance divided by rate. Just a helpful tool for visualizing how to rearrange these formulas. Some examples. These are some Carroll High School track records. Maybe not necessarily up to date. What we're going to do is calculate the average speed for each Carroll High School track record. So what I am going to do is calculate the right column, and that would be the women's records. So I'm going to calculate the women's records, and then if you're watching the video out there, your job is to calculate the men's records once you have the idea. And at some point, I am going to check your binders, and I'm going to verify that this left column is complete. Whenever you're working a physics problem, I have a couple of criteria that have to happen. I need to see a formula first. What is it you did? In symbols, what are we doing here? Now we're looking for average speed. That's V average velocity. So I'm looking for average velocity, and I'm going to find it by using distance divided by time. In your homeworks, quizzes, tests, part of the credit you get is just showing me the formula, the right formula, the one that we're going to need. So I need to see the formula. And it is going to get a bit tedious because you're going to write V average equals D over T probably 10 times. But I need to see it, and you need to write it down so that we know exactly what we did if we have to have a conversation about what happened. So the distance. This is a record set in 1983 for the 100-meter dash. So the distance, we have 100 meters. And over here, the 12.4, that would be 12.4 seconds. That is your time, 12.4 seconds. So that's our time, that's our distance, just so that we're clear. And so the average velocity is 100 divided by 12.4. I've already calculated this, 8.06. And the units are meters per second. So a quick recap on all the things that I want to see when we do a problem. Here's what I'm going to look at when we're grading it. Did we see the formula with symbols? Formula with symbols. There's number one. Did we see the values inserted into the formula? That's number two. Over here, the correct answer, that would be number three. And units. That's number four. All four of these things are required to get full credit on homework questions, quiz questions, test questions, etc. It's just a good habit to show all of your work. Units are necessary. So let's make sure that we show everything that's on here. Next one, set in 1997. The 200-meter dash. Here's our distance. With a time of 26.7 seconds. There's my T. First thing, start with a formula. V average equals distance over time. We're looking for average speed. Equals, plugging in my numbers, I found D is 200 meters. And T is 26.7 seconds. We'll put this into our calculators, and what we find is 7.49 with units. Units need to be in the answer. It is not enough that they are here. It needs to be in the answer. 7.49 meters per second. The 400 meters, here's our distance. Set in 1993 with a time of 59.4 seconds. First, the formula. Velocity average, distance over time. Showing my values, distance is 400 meters. Time is 59.4 seconds. And what I find is 6.73 meters per second. The 800 meters, we have a tie set in 1995 and then tied in 2011. 2 minutes, 25.87 seconds. First, let's figure out what we have. We have a distance, 800 meters, 2 laps around the track. My time. The problem we have with time is that it's in minutes and seconds. If we want to have something in terms of meters per second, it's going to have to be changed. So 2 minutes, there's 120 seconds, plus 25 more, 145.87 seconds. If you do not convert to seconds, your answer is going to look very strange. Make sure that you are using just seconds. The formula, putting in our values. Calculator says 5.48 meters per second. Remember, we've got all 4 of the things that we need here: the formula, the raw numbers, the answer, and the units. Next record, the 1600 meters, 4 times around, with a time of 5 minutes, 29 seconds. First thing we need to do is convert it. Seconds, 5 times 60, there's 300. Add in 29 more. I think most of you are capable of doing this in your head, but I know you're doing this in your calculator anyway. Try to practice just using your mental math. You'll see a lot of improvement in your math skills. Formula, average velocity equals distance over time. Distance is 1600 meters. Time is 329.6 seconds. This one we can put in our calculator. It's going to be 4.85 meters per second. The 3,200 meters. Distance is 3,200. That's about 2 miles. Time, 12 minutes, 24.17 seconds. Converting our time into seconds, 744.17 seconds. Formula, average velocity is distance over time. Distance is 3,200 meters. Time of 744.17 seconds. What we find is 4.30 meters per second. The women's 4x400 meter relay. Now we have a time for the entire relay team, all 4 runners. It takes them 4 minutes, 14 seconds. Each runner ran 400 meters, which means the team as a whole ran 1,600 meters. The time we need to convert to seconds. 4 minutes, 14.8 seconds. $254.8 seconds. Your formula, average velocity is distance over time. 1,600 meter distance. 254.8 seconds for the time. And we find an average velocity of 6.28 meters per second. Some questions here. What happens to the average speed as the distance increases? What happens to the average speed, as a V average, as the distance increases? Let's take a look back. So we have the shortest distances at the top, slightly longer distance, longer distance, longer distance. Look at the average velocities. Shorter distance, 6.73. Longer distance, 5.48. Longer distance, 4.85. Longer distance, 4.30. What happens to the average speed as the distance increases? It decreases. Is that logical? If you run as hard as you can, as fast as you can, you burn out faster. If you pace yourself and run a little bit slower, you can run for a lot longer. You can run a lot farther. Is that logical? Yes. If Dickie Bishop could run the 3,200 meter race at the average speed that Chris Reitzel had won for the 800 meter record, what would Dickie's time be? Here's what we're going to do. We are going to swap out for the women's numbers. So we are looking at this runner. And these runners. We are looking for what would the time be. So look at our formula, rearranging it for time. Time equals distance divided by the rate. Or in physics terms, we would say time equals distance over the average velocity. The distance, 3,200 meters. And the average velocity for the women's 800, 5.48 meters per second. This one will go into the calculator. And we have a time of 583 point, let's say 9. And that is per second, which makes it seconds. Let's put it back in terms of minutes and seconds. So what we have is a time of 9 minutes. .9 seconds. I'm going to say. Nine minutes, 43.9 seconds. Let's look at the actual just for comparison. The actual 3,200 meter time. Found here. 12 minutes, 24.17 seconds. So if this runner could run the 3,200 meter race at the record speed for the 800 meters, they would be finishing a lot faster. How about this? How far would our 4x400 meter relay team beat this record in a 1,600 meter race? This one's a little more complex. We're going to have to look at a couple of different things. So, how far would they win? We have to know how much faster they got to the end. So, time, distance over average velocity. We're going to do this for both. We're going to do it for this record, individual, and the 4x400. They are both at a distance of 1,600 meters. So I'm going to fill in both of these as we go along. Say this one's relay and this one's our runner. The relay team, 4x400, has an average velocity 6.28. Meters per second. Bordner has a velocity of 4.85 meters per second. Going into the calculator, 1600 divided by 6.28. The relay team is taking 254.78 seconds. Our individual runner, 329.90 seconds. Here's what we see. It's that the relay team is 53.19 seconds faster. And if you're curious how I got this number, we're talking about the longer time minus the shorter time. And that's our 53.19. It's a little off over here because of rounding. Actually, it's a little off because I wrote a 9 instead of a 2. That's better. There we go. That's better. So if they were trying to outrun them, how much farther ahead would they be if they had continued running around? How much farther would they be? How much farther ahead would they be? And what we're going to use is their average velocity, because these are the winners, 6.28 meters per second. And how much time would they have kept running before our individual runner would have finished? 53.12 seconds. This is how much time the relay team was running before the other one finished. Put this in your calculator, and the last relay runner is 323 meters ahead of our individual runner. If you are lost with this example, now that you've seen the whole thing, you should go back and try this with the men's numbers using Blake Mills and your 4x400 meter men's team, and try to work it out and see how you come up with it. And after you have tried that, then come talk to me and we can address this or any of the other examples. Thanks for watching. This is the end of the first video of Unit 1. I will post the next one soon.